Hello everyone, this is day 15, question 2 of our Leetcode activity. Remove all adjacent duplicates in string. You are given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after all the such duplicates removal have been made, and it can be proven that the answer is unique. So let us understand the question first through this example A B B A C A. So here you can see A B B A C A. So which are the obvious ones which are we can remove? So we can remove B B as they are equal and adjacent. After we remove B B, we get A which are adjacent and equal. So we have to remove them as we are doing this repeatedly, not just once. So now we find remain are remaining with the string CA. So these are not equal and adjacent. So this is our final answer, which is CA. So so the question we have understood the question now that we repeatedly remove. So same as here. So here you can see XX is equal and adjacent. We remove that. So we'll get A Z Z Y. So now Z Z is also equal and adjacent. So we remove that. So finally we'll only be remaining with AY. So, how we will solve this? We'll use stack. We'll use stack for this. How? So, let us go through and dry run what we will do. So, here we'll iterate through this string. Now, what we'll do? Firstly, if the stack is empty, we'll add the current element to the stack. Current element is A. We just push our element A into stack. Okay. We go further. Now check if our top element and the current element are equal. Are they equal? No, they are not equal. Push the current element into the stack. Now again, go further. Is our current and the top element equal? Yes. So go further and pop this. Are our current element and the top equal? Yes. So pop this, pop the top element and go further. So again our stack is empty. So we'll add our current element to the stack. Go further. Is our current element on the top of the stack top element equal? No. Add the element current element to the stack. And we have iterated the whole string. So whatever we have in the stack, we will make a result string. So and we will add everything in our stack from the top, but the bottommost element will come first and the top element will come last. So it will be reverse. We'll not add CA, we'll not add from top to bottom, from bottom to up. How we will do this? We will first declare an empty string, and we will do here, you can see st.top plus result. So whatever we have, that will be further at the end. We'll first add the top. So how we will do it? So this is empty. So here A will be added, and we will pop A. Now here it is C. So st dot top plus result. So C is our top plus result. What is our result? Result is A. So top is A. So here this will be C and not AC. Why? Because we are adding in the stack. So the first element in the string will be at the bottom, so we need to reverse the order. And whatever we get this result string, this is our answer. You can see CA is our answer. Why does this work? If you think closely, you can observe how this question is related to the valid parenthesis question. So how can I say like valid parenthesis and this has relation? See, consider the letters as parentheses. So A is round, B is curly, again A is round, C is square, A is round. Now, so whenever we see the first occurrence, we do it as open bracket, second occurrence as close bracket, third occurrence as or open bracket, open close. We go on further. Or that is not the point. I'm just giving an intuition that how you can connect the things. And this is not a perfect analogy. It's just for to develop some outside the box logical thinking. So here you can see that whenever there are adjacent elements, they are like a valid parenthesis. So when we are solving an equation, we go from uh, inward to outwards. So here, once we calculate this, we delete this. Now we calculate this bracket and we delete this. And now whatever remains, these are the non-valid parentheses. And this question is asking return the non-valid parentheses. That is the whole question. That repeatedly delete the equal and adjacent and repeat whatever remains, which are not a string which should have no adjacent elements which are equal. That is the non-valid part of the parenthesis. I know it's a stretchy logic, but if you think about it, you can connect the question, and that is why we use stack here. Why does stack help? Stack helps in this. Stack helps in checking that once we reduce our the middle part, is there anything which remains to be connected? Like after deleting this BB, is there anything remaining which can cancel out the part before BB? Because that will be in the stack. As we are adding the elements, that will be in the stack. And once we go further, we'll check that if that can be cancelled. So whatever remains in the stack is the things which cannot be cancelled by other elements, other equal elements, and that is what remains. So that is what we were doing in valid parenthesis. We were checking if the stack is empty. If the stack is empty, that means all are valid parentheses and we return true. What we are doing here and there also was if the stack is not empty. So these are not valid parentheses and we return false. We only here what we return is the non-valid part which is remaining in the stack, and that is the logic. Think about it, you can genuinely create some connections in questions of same kind this way. I find it fun to do. So this is the solution for the question remove all adjacent duplicates in string. Thank you.